North Carolina's barrier islands, it's a tale of two coasts, the beach and on the other side, the marsh, both facing the same rising tide.
I think the thing that concerns communities the most in places like this is how is the shoreline going to change over time.
Over the decades, the North Carolina coast has been hit many times by tropical storms and hurricanes. While experts say climate change won't increase the number of storms in the future, they say they'll be stronger. Hurricane Erin, for example, never made landfall in mid-August of 2025. It stayed 200 miles offshore, yet its wind field and storm surge still reshaped the coast. Months later, twin storms Imelda and Humberto sent powerful surf into Buxton, undercutting homes and pulling them into the sea. For the communities that call this coastline home, the danger is only growing on both sides.
We need to protect the infrastructure that exists here.
Scientists like Jana Haddad are studying how tides and waves shape our coasts and how to protect them. Their focus is on what are called living shorelines, natural defenses helped along by humans. The waves, tides, and their impact all feed into powerful computer models, showing how future storms could reshape the coast.
And that tells us, like, will the living shoreline actually dissipate waves and mitigate coastal erosion under these scenarios? Or will it not work? And we need a different type of solution for that community. The computer models, the simulations, are a really key tool that we use. You know, we want to maintain the recreational use of this beach. You can see there's a lot of folks out here enjoying the beach today.
Sure.
And the wave dynamics today and in the future are going to impact how wide the beach is over time. So you might, you know, we want to make sure that there's enough beach width for the future to be able to enjoy the beach here.
From a distance, the ocean looks calm, but beneath that surface, those wave dynamics are always at work as that energy nears the shore, rises and breaks, shaping our coast, sometimes cutting it apart.
On a normal day like today, these waves typically will be depositing sand on the beach a little bit. During a storm, however, the water level might be even higher. The wave energy literally essentially clawing at the sand and taking it out shoreward. The dunes along our barrier islands here in North Carolina are our first line of defense because they're literally high and also because they're vegetated. And so the vegetation on the dunes kind of holds the dune in place for us.
If you travel just a short distance from the dunes and surf, you'll get to the other side of the barrier island with its own set of wave dynamics. It's quiet, but driven by the same tides and wave action. The landscape is a lot different and requires a totally different approach.
We had to carry a lot of heavy equipment, so that was kind of part of it. It was really useful to have lots of folks.
While a graduate student at UNC in 2022, Haddad placed sensors through the grass and water, measuring how marshes absorb energy and blunt the force of waves. Walking out here, what first struck you?
Well, I came out here knowing, like, we were, planning on measuring waves in the marsh. That was the goal of the work. We wanted to look at how waves are transformed from the kind of open ocean to, once they reach the marsh, their energy starts to dissipate and the waves literally look different.
Living shorelines. They help a marsh trap sediment and dissipate waves that can be destructive during a high tide or worse, a storm.
These systems here, they really absorb kind of like a sponge.
These living shorelines are built on what's called a sill. Yes, like a windowsill, set low along the water's edge. These sills are made from things like rock, wood, or some types of biodegradable matting. They work with nature, not against it. And oysters are a critical component.
Well, just here, actually, there is a great example of two different types of living shoreline sills that the folks have installed here. So this is a rock sill, and you can see it's kind of been here for a little while because there's a lot of oyster growth on it. It's a lot like riprap or like a revetment. It's just large rocks, and then the oyster growth just happens because this is a brackish saltwater area that is really hospitable to oyster growth. And the other sill is made up of modular poured concrete sections that are placed there in front of the marsh. The oyster growth is great for things like water quality improvements, but it also adds to the wave energy dissipation element. So the more oyster growth, the kind of larger the sill becomes, like it just takes up more volume.
Haddad says protecting the coast isn't about a single fix. It's about building layers of protection, natural and engineered, working together when storms arrive.
We want these nature-based solutions to be just one element of a broader, super comprehensive, well thought out plan where all the different elements work together, because as we said earlier, these are dynamic systems.
Along our coast, there is hope in what science and nature can achieve together. That resilience doesn't have to mean resistance. Each project adds to a larger plan, one shaped by data, driven by design, and rooted in the belief that the coast can and will endure.
Communities really care about what is the shoreline going to look like in 10 years, 20 years, and what can we do to address the challenges that we're going to face as a community.
Thanks for watching. If you like science stories like this, click subscribe now for more Science-C in PBS North Carolina.